Hey everybody, this is Mr. Longo, and this is going to cover geometric sequences. So geometric is a little bit different than arithmetic because instead of having a common difference, we now have a common ratio, which means we're going to be multiplying for geometric sequences. So the ratio between terms is always going to be the same non-zero number. Okay, it can't be zero. Same thing, a sub 1 is the same as a, it's your initial term. R represents the common ratio. Ratio is equal to the term divided by the term before it, which makes sense. And of course, one of the formulas for a sub n is the ratio times the previous term. All right? Now, if we're looking to find the nth term of a geometric sequence, our formula is a sub n is equal to the first term times the ratio raised to the number of terms minus 1, and of course the ratio cannot be 0. So what we're going to do is just kind of jump in now, and what we're going to do is find the first 4 terms of this geometric sequence. So to do this, what you need to do is kind of start out by a sub 1, a sub 2, a sub 3, and a sub 4. And we're just going to substitute in 1, 2, 3, and 4. So we have 1/5 times 2 to the first power, and that's going to give us 2/5. And the next one, we have 1/5 times 2 to the second power, which will give us 4/5. 1/5 times 2 to the third power is going to give us 8/5. And then as you can see the pattern, we're doubling each time, 2/5, 4/5, now we're 8/5. Without even doing this, you should know that it's about to be 16/5, but of course you can check. 1/5 times 2 to the fourth power is going to give you 16/5. So it's doubling every time, so we can see that our ratio is 2. And that's because that's the number that's, increasing in power each time you go from one term to the next. So now what we're going to do is we're going to write a rule for the nth term of a geometric sequence. So to do that, we have to think in terms of a geometric sequence now. And that is, we are now multiplying to get from one term to the next term. So we're not adding anymore. So how do you get from 5 to 15? You have to multiply by 3. And then we're going to multiply by 3 again to get to 45. So our common ratio is 3. And of course we need the first term, and our first term, a sub 1, is equal to 5, also known as a. And what we're going to do is write a rule for the nth term and then find a sub 8. So to write the rule, our formula is a sub n is equal to the first term times our rate, which we found is 3, our common ratio, raised to the n minus 1 power. Okay? So to find a sub 8, we just have to say a sub 8 is equal to 5 times 3 raised to the 7th power, because 8 minus 1 is 7. Type that in your calculator and you will find out that it's 10,935. Okay? So that's a rule, and that's how we find that 8th term. And I mean, you could just keep on multiplying 45 times 3 and then that times 3. You can keep on doing that if you want, but that takes a long time. So it's always nicer to have a little bit of a shortcut. The next example is the same thing. So why don't you pause the video really quick and give it a try. Click play as soon as you're ready. Okay, so for this, our rate is 1/3. Now, as mentioned before, it's the term divided by the previous term, or you could always ask yourself, 6 times what will bring you to 2, and that would be 1/3. So each step we go, we're multiplying by a ratio of 1/3. So our ratio is 1/3, and our first term is 6. Formula: a sub n is equal to the first term times our ratio raised to the n minus 1. So if we were going to go find the sixth term here, a sub 6, would be equal to 6 times 1/3 raised to the 5th power. 6 minus 1 is 5. Type that in your calculator, and you're going to end up with 2 over 729. All right, so that's how you do it with when you're given a list of terms. The next couple examples. We now have our fourth term is equal to 12. Our ratio is 2. We want to find a sub 3. So now this one is a little bit different because we aren't given the same, we're not given our first term. So what we need to do is we need to go find the first term first. So we have a sub n is equal to our formula, our first term times the rate, our rate is 2, raised to the n minus 1 power. And now we need to do is we need to substitute in what we do know. So we know that a sub 4 is 12. So we know 12 is equal to a times 2 raised to the 4 minus 1 power, because we know that that is our fourth term. Okay, a sub 4 is equal to 12. So now we just have to say 12 is equal to 2 to the 3rd power is 8, so 8a. So a is equal to 3/2. So once we know a is equal to 3/2, we can substitute that in and find a sub 3. So we're just going to go say a sub 3 is equal to our initial term, 3/2, times our rate of 2 raised to the 3 minus 1 power, and that's going to give us a sub 3 is equal to 3/2 of 4, which is going to give us 6. Okay? And of course, you could just type that in the calculator if you want to. So why don't you pause the video and try the next example. Give it a shot. Okay, so we know a sub 5 is equal to 32. So we have 32 is equal to our initial term times the rate given as 1/2 raised to the 5th term minus 1. So all we did there is substitute in what we knew. So 32 is equal to a times 1/2 to the 4th power, which would be 1/16. Solve for a by multiplying both sides by the reciprocal, and we know that 512 is equal to a. So we have a now. All we have to do is substitute it in to find the second term. So a sub 2 is equal to our first term, which is 512, times our rate, 1/2, raised to the 2 minus 1 power, which is just 1. So half of 512 is going to give us 256. Okay? So again, that's how you use the formula to find the first term and then use that new term to find other terms. Okay, so the last thing we're going to talk about in this video really quick is the sum of a finite geometric series. Now, we say finite because our next video is going to be how we find the partial sum of an infinite series. So until then, to find the sum of a finite geometric series, we have the formula, which is our initial term, times 1 minus the rate raised to however many terms we have, divided by 1 minus the rate. And you need to know that the rate is not allowed to be 0 or 1, okay? Because if we have 1 in the denominator, that's undefined. So I'm going to do the first one with you, and then I'm going to give you a hint for the second one. You're going to give it a shot, and we're going to be done with this video. So we need to know what a sub 1 is. So our first term is going to be a sub 1 is equal to 4 times 3 raised to the 1 minus 1 power. So that's 0, and anything raised to the 0 is 1. So a sub 1 is equal to 4. So now we know our a value. So if we're going to find the sum of the first 10 terms, so we're going to find s sub 10, That's going to be equal to our initial term 4 times 1 minus our rate raised to the 10th power divided by 1 minus our rate. And all we need to do is type that into our calculator. And once you type that into the calculator, you're going to find that the sum of the first 10 terms is 4 times that big number in our calculator is going to give us 118,096. All right, and again, you just type it in the calculator. 1 minus 3 to the 10th divided by a negative 2. Multiply that by 4. You're good to go. All right, so the next example is the last one for this video. Now, here's the thing. You know the first term now, but you need to use what's given to find the rate, and you need to use it to find how many terms there are. But we've done that before in other videos. So you just need to figure out your rate, your number of terms, plug it into the formula, and then go find S sub whatever how many terms there are. Give it a shot. First term is a sub 1 is equal to 3. Our ratio is 2. We're multiplying by 2 every time. 3 times 2 is 6 times 2 is 12. Times 2 is 24. Times 2 is 48. Times 2 is 96. Times 2 is 192. So 1, 2, 3, 4, 5, 6, 7 terms. So this sequence has 7 terms to it. So we just need to use our S sub 7 formula is equal to our first term times 1 minus 2 raised to the 7th power divided by 1 minus our ratio of 2. Type that in our calculator, and the sum of the 7 terms is going to be 381. All right, so that's it for geometric sequences. It's similar to arithmetic, except for the fact we're no longer adding from term to term with a common difference. We are multiplying from term to term by a common ratio. This is Longo, and I'm out. See you, bye.